All right, hope everybody's enjoying their Corona vacation, right? We're gonna do the notes this way for at least while you're off. I'm hoping this works pretty well because I'm gonna go over the same things I would have gone over in class. The difference is you're gonna need some paper of your own to do this. Obviously, I didn't have a chance to give you the note packet for this couple of chapters here. This is chapters 10 and 12, okay? So you're going to need to get yourself some paper so you can write some of this down here. That's going to be important so that you can understand it and learn it. And then, of course, you'll have some problems and stuff like that that you're going to have to work on for homework, okay? So 10 and 12 is what we're doing together. That's the next couple of chapters. In fact, if everything goes to normal plan the rest of the year, there'll be several chapters that we're going to combine together. Okay, so we're going to do this quite often. This is going to be 10 and 12. They're both related to each other, and they're both based on this word called stoichiometry. Okay, stoichiometry is basically chemical math. And I know some of you are just shaking and shuddering right now because I said math. It's not hard math in any form or fashion, but it is math nonetheless. So we are going to be taking amounts and measurements and numbers and working with them in terms of chemical equations. Okay, that's what stoichiometry is all about. All of stoichiometry is all based on one fundamental unit in chemistry, and it's called the mole. Right? But it's not that mole. That's not the mole we're talking about. That's the animal mole. It just happens to be spelled the same way. We have some fun with it. He sort of is our symbol for when we're talking about the mole, but it's not really what we're talking about. So what we want to be able to do is find out the amounts in the matter that we're studying. Okay? Is there any way to count all of the atoms or all of the molecules? And we know that there isn't, because atoms and molecules are so small and so numerous, there's no way that we can actually count them. Right? We can measure things like mass, we can measure volume, but we can't actually count the particles. But if we could, what would you count by? Would you count every one individually? Right? Would you count by fives? Would you count by dozens? Would you count by hundreds? In fact, none of those are even close to what we would need to count by if we were going to count them. You know, if you're buying eggs, you usually buy them in dozens. Or if you buy them in donuts, you buy them in dozens. But really, the word dozen means the word 12, and it doesn't matter what you put it with, right? If you have a dozen people, that's 12 people. If you have a dozen pieces of paper, that's 12 pieces of paper. It doesn't matter what you put the word dozen with. So the word mole is simply going to mean a number, okay? And it's going to help us to count, but we don't have to count by ones because we're going to be talking about billions and trillions of these atoms and molecules at one time. Okay? So just like the word dozen, the term mole is used to represent a certain number of particles. So that term mole is going to be really important to us, and it just means a number. So what is the mole? Right? The mole came from a set of experiments done by a chemist, an Italian chemist named Amedeo Avogadro. In the 19th century, Avogadro did a lot of experiments, especially with gases, and he determined that there is a certain number of particles in a certain amount of gas always. And although he was working with gases, this works with all substances. And so he deemed this number a mole of something. Okay? And it is actually essential to everything that we do in chemistry. 1 mole is 6.02 times 10 to the 23rd power. All right, now that's an absolutely ridiculous number. If you take a moment and you actually write this out, right? If we write this out as an actual number with all the zeros put in, this would be 602, and then it would be 21 more zeros, because remember the decimal place here, this decimal place right here is going to be moved over 23 times, so it moves past the 0, the 2, and then we have 21 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now let's go put the commas in like we normally would for a big number, right? We put a comma after every 3 zeros. So we put our commas in. Sorry for the writing, I'm writing with a mouse, of course. All right, so there's all of our commas. Now, let's see what this number actually would be. Right? If we went through and said this number out loud, what would it be? Well, this portion right here, right? We know that's the thousands. Or this is the hundreds, I'm sorry, because I'm not thinking. This is the hundreds. This is the thousands. Right? So this would be the millions. And then we have the billions. And then this would be the trillions. All right, what comes after trillion, you remember? It would be quadrillions. And then quintillions. And then finally, this would be sextillions. So that means this number would be 602 sextillion. 602 sextillion of whatever you're talking about. Now, that is an absolutely ridiculous number, right? That's not a number that you can conceive of in your head. I mean, generally, when you say the word million, most people cannot picture a million of anything. And we're way, way, way past a million here. All right, this is 602 sextillion. If we were in class, I would go through a whole demonstration and show you what 602 sextillion kind of would be like. But suffice it to say, you have never or will never see 602 sextillion of anything that you can see with your eyes. Right? Everything that is big enough for you to see with the naked eye is way too big to have that many of it. We've never had 602 sextillion of anything except for things like atoms and molecules and microscopic things. All right? So we know that this has to be a huge number like this because we're talking about super, super, super small things like atoms and molecules. 602 sextillion atoms and molecules actually isn't that much at all, right? But for things like people or eggs or donuts or whatever, that would just be a ridiculous number and would be silly to use. So this is appropriate. 1 dozen eggs equals 12 eggs. That seems very appropriate. But this is not appropriate. We would never use the term mole with eggs because 6.02 times 10 to the 23rd eggs is more eggs than have ever existed in all of history. If you add up all the eggs that have ever been here since the beginning of time, they would never even get close to that number. Okay, that's why that number is ridiculous to use for that. But this is totally appropriate. Right? 1 mole of iron atoms is 6.02 times 10 to the 23rd iron atoms. To tell you the truth, that'd be a pretty small amount of iron. Right? That'd be a little piece of iron that you could easily hold between your fingers. That's what that amount of iron would be. So when we're using that number, we only use it with things like atoms and molecules because it's the only way that that number makes any sense. By the way, since the number is 6.02 times 10 to the 23rd power, over the years, people have looked at that and go, hey, 10 to the 23rd power. That's kind of like a date, right? October the 23rd. So every year on October 23rd, starting at 6:02 a.m. and ending at 6:02 p.m., we celebrate Mole Day. It's a real thing. It is. We didn't talk about it earlier this year because you didn't have any clue what a mole was yet. But I do want you to know that it is a thing every single year. All right. So how are we going to use this? Right? Well, one of the first things that I want you to do is I want you to be able to change units between units. So if we want to have moles of something and we just want to figure out how many of that is, we have to use the conversion factor. We talked about conversion factors way earlier this year. Okay, so we're going to go back and talk about them again. Remember, a conversion factor is just one unit over another, and they're equal to each other. So for instance, if I wanted to know how many eggs were in a dozen eggs, I could write 1 dozen eggs over 12 eggs. Right? Or I could write 1 mole of atoms is 6.02 times 10 to the 23rd atoms. Right? They're equal to each other. By the way, you'll notice the abbreviation for mole is MOL. I know. You're welcome. We don't even have to write the E. I shortened it so much for you, so it makes it so much. No, I didn't. I mean, that's just somebody somewhere along the way figured out that they should abbreviate it MOL instead of having the E on it. I know it's kind of a silly abbreviation, just taking one letter off, but that's how we write it, okay? So if we wanted to convert moles into another unit, right, we would have to set this up. I want you to be able to show your work when you are converting units. Right? You cannot just do things in your head. You cannot just have a calculator sitting in front of you and type it in your calculator and then just tell me what the answer is, because then I don't have any clue how you did it. Even if you got the right answer, I don't even know if you were doing it the right way or you just guessed. So we have to be able to show our work. So for instance, if I ask how many students are in 1 mole of students, well, you can already tell me what the answer is going to be to this. But I want you to be able to show your work. So the thing that we always do is we set this up so that we take our given, so our given is 1 mole, and then we show it multiplying by a conversion factor. So for instance, this is how it would be set up, right? The given in this problem is 1 mole chemistry students. And we're going to multiply so that our moles of chemistry students cancels out, and we put on top what they're equal to, which is 6.02 times 10 to the 23rd chemistry students. And of course, the answer is 6.02 times 10 to the 23rd because you're just taking 1 times that number. And that looks like a lot of work to do for a problem like that, because that problem is really simple. But then you get to a problem like this. How many iron atoms are in 6 moles of iron? Well, that's not so obvious, okay? So now we're going to take our given. So our given here is 6 moles of iron. So we always take our given from our problem. We're then going to multiply by a conversion factor. A conversion factor always has units on the bottom and units on the top. The units on the bottom have to cancel what units we started with. So I don't want moles of iron anymore, so I'm going to put moles of iron on the bottom. And then I'm going to put what I want it to be on the top. So what am I looking for? I'm looking for atoms of iron. Okay. So these are the units that I want. I want to get rid of moles, so moles goes on the bottom, and I want to go to atoms, so atoms goes on the top. Now I'm going to fill in the numbers. How are they equal to each other? Well, I know that 1 mole of iron, 1 mole of anything really, is 6.02 times 10 to the 23rd. All right? And so if I hit equals, I know that I have to take 6 times this number, 6.02 times 10 to the 23rd, to get my answer. Now, nobody wants to do this by hand. Nobody wants to try to do this in their head. You want a calculator. Since you're at home, I don't care what calculator you use. You can use a calculator on your phone, you can use a calculator on the laptop or on a Chromebook or whatever you're working on. I don't care. But you have to use a calculator with this. I do want you to remember that the calculators always take this portion that's right here, right, and replace it with one button. So this portion right here is replaced with one button on any calculator. I don't care what calculator you're using. I don't care if it's the one on your phone. And remember, if you need a scientific calculator on your phone, you have to turn your phone so that you have the bigger version of your calculator, not the small basic version of a calculator. But there is always a button on whatever calculator you're using. It's a special button. We talked about this earlier this year. On your calculator that you were using at school. I don't know if you have that with you at home or not. But if you do, remember, there is a button. Sometimes it says EE or EXP, or sometimes it actually shows times 10 to the whatever, okay? So you have one of those on your phone or whatever other calculator you might be using also. There's a special button there. So when you type this in, you would type in 6 times 6.02, then hit that special button, whatever that special button is, and then 23. When you're done, you should get this as your answer. And again, depending on your calculator, it might show you that looks slightly different, but that's what that would be written as. And our answer is whatever units didn't cancel. My moles of Fe canceled. My moles of Fe here canceled. So I'm left with atoms of Fe. Okay, and then of course I want to circle that final answer of mine. I want you to make sure you can do this. I know right now you're just staring at the screen and maybe you're writing some things down. Hopefully you're writing some things down. But you need to try this, right? You need to get out a calculator and make sure you can get that same answer I'm getting. Oh, by the way, we need to worry about significant figures. I know, again, it's been a while, but remember, significant figures are how many of these figures match what the figures were in our original problem. In our original given, we had 3 significant figures, 6.00. That's 3 significant figures. That means this answer can only have 3. So that means this 4 here, I'm going to have to get rid of this 4. So we'll go back and we'll erase, because I only want the 1.20. That gives me 3 significant figures. Okay? I'm going to go ahead and erase all of this so you can see a much neater version. Oops. Gosh. Okay. You know it's Monday. You know it's Monday because I cannot do math while I'm sitting here in front of this computer. 6 times 6.02 is not 1.204, it's 3.61, because I am not smart. Sorry about that. I apologize. You can laugh at me all you want to while you're sitting there at home. So this is the number you should be getting. If you were freaking out and doing this problem and wondering why I was getting the other answer, now you know, because I'm not smart. So there's your answer. I apologize. Okay, so let's try another one of these. This time, I want you to try to do this. And hopefully you have better luck on your math than I was doing, because I was trying to do this in my head. All right, so it says how many moles are in 2.17 times 10 to the 23rd molecules of water? Okay. So here's what I want you to do. Write down on your paper 2.17 times 10 to the 23rd molecules H2O. By the way, if you want to abbreviate molecules, you can do that. But you can't use MOL, because that already stands for moles. You can't use MOLE, because that also looks like moles. So you'd have to write at least MOLEC if you want to abbreviate molecules. Or you can just write the whole word out. Anyways, so you're writing that given first, and then you're going to hit a multiply sign, and then you're going to write down the conversion factor. Pause this video, try it out, and then unpause, and I'll show you what the answer is. Okay, here's the answer. So this is what your setup should look like on your paper. Right? 2.17 times 10 to the 23rd molecules H2O. And then we put multiply. On the bottom, I had to put molecules of H2O because the units from the beginning, the given, have to match the units on the bottom because they have to cancel. Then I put moles on the top. You notice I put moles on the top. So I want to go from molecules to moles because that's what the problem asked me to do, molecules to moles. Notice the 6.02 times 10 to the 23rd went on the bottom this time. Why? Because 6.02 times 10 to the 23rd is how many are in a mole. And since moles this time had to go on the top of my conversion factor, then the 6.02 times 10 to the 23rd is how many are in a mole. That had to go on the bottom. So this time you're going to divide. So this is 2.17 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Once again, nobody in their right mind wants to do this on paper or in their head. You got to do this on a calculator. You take 2.17 special button 23 divided by 6.02 special button 23, and you get 0.36. Now, we have 3 significant figures in 2.17. So our final answer has to have 3 significant figures. So I have to write it as 0.360 because I needed to have 3 digits there that are significant. Right? Now this last example here, this last example is a little bit tricky, and I'll show you why in a second. It says how many atoms of hydrogen are in a mole of water? So you have a mole of water, which has hydrogen in it, but it is not hydrogen. But I want to know how many individual atoms of hydrogen could you find in a mole of water molecules. So this isn't going to just be one conversion factor this time. This is going to have to be 2 conversion factors. So again, we'll do this one together. So we're starting off with 1 mole of water. Okay. Now, once we set this up, we can already see where this is going to have to go. This is moles of H2O that I started with. Therefore, it has to match the unit on the bottom of the first conversion factor. Has to. Not negotiable. I don't have to put 1 here necessarily, but I do have to put the units to be the same as the units at the beginning. So moles H2O has to match moles of H2O. Now, this wants me to go to atoms of hydrogen. I cannot take atoms of hydrogen and put it on the top here because moles of H2O and atoms of hydrogen are 2 completely different things. They're not related to each other in any way. But I could figure out how many molecules of H2O are in a mole of H2O. I know that. I know that 1 mole of anything is 6.02 times 10 to the 23rd of it. By the way, you should be memorizing that number, okay? 6.02 times 10 to the 23rd molecules are in a mole. Like I said before, this is going to take us another conversion factor. Now, how do you know what goes on the next conversion factor? Well, on the top of this one is a unit I don't want anymore. I don't want molecules of water. So molecules, H2O, all right? Molecules of H2O are going to cancel. So I'm going to have to put molecules of H2O on the bottom so they cancel. What am I trying to change that into? Well, remember, I'm trying to change it to atoms of hydrogen. Now these are related to each other. In 1 molecule of water, there are 2 H's. So I can put that in. And now finally, moles of water canceled, molecules of water canceled. And now I finally have my atoms of hydrogen, which is what the problem was asking me for. Now, how do you do the math? I'll just go across the top. 1 times 6.02 times 10 to the 23rd times 2. So basically, we're just taking 6.02 times 10 to the 23rd times 2. By the way, here's where your answer is 1.204 times 10 to the 24. But whatever. So you can do this on your calculator. You can figure out what the answer is. I'm going to erase this, and then I'm going to replace it with something that's much neater. Now, this didn't have any numbers in the original problem. It just said in a mole. So it didn't tell you how many significant figures were in our original problem. So I can have as many significant figures in my answer that I want. It didn't matter how many I chose. So I kept the 1.2, but here it wouldn't have mattered. Okay? All right, that's the beginning of the notes. There'll be another one of these to come that will continue through chapter 10 and chapter 12. Well, actually, there'll be several more. I'll split this into several parts. And each part, then, I want you to then go and work on some of the problems in the homework before you go to the next part. Okay?